So we were discussing these concepts. Yesterday we discussed about how to calculate the errors. Remember? So what are the ways which you can do? First is you can find something called as absolute error, then average absolute error, then you have fractional or relative error, and the last one is percentage error. So then I told you about the combination of errors, right? So when you talk about the physical quantity, then a physical quantity need not be a single parameter which can be calculated, right? See, for example, when you Hariharan and Hariharan together.
So can you repeat that, sir?
Are you able to hear me is what I'm asking.
Now I'm able to hear you.
Okay. So now we'll be discussing about combination of errors in the sense when there are certain physical quantities which are combination of other physical quantities. Okay. So read the statement. When we perform an experiment, right? So when we perform an experiment, what can happen? They involve several measurements. Okay. So when those several measurements are taken into consideration, we will try to calculate how the errors occurring in each reading will affect the overall value. Okay. So we must know how the errors in all the measurements get combined in a sense. For example, if I want to calculate the sum of 2 times, okay. Let's say my job is I need to calculate the total time taken by 2 persons who are running on a track. So let's say one person has taken 5 seconds, the other person has taken 7 seconds. Okay, the sum of these 2 times I'm trying to report. Now what will happen is, see when a person is running on a track, what is the device used? Again, a stopwatch, right? So do you think that stopwatch measurement taken by anyone is accurate? Or will there be an error? Why will there be an error? So there is a possibility where a person, when they are trying to cross the finishing line, okay, it is not necessary that the stop is pressed exactly at the right time. There could be some microseconds error at least which is going to occur. Suppose I do that experiment, I might get one value. Your PT sir is doing the same job. Maybe he can be more accurate compared to me because I'm not experienced. Like you do, it might be something else. So each person, when they do it right, there will be a slight error that is definitely going to occur. Let's say this kind of an error is occurring both in T1 and T2. T1 is the time taken by the first person to complete 100 meters. T2 is the time taken by the second person to complete the same 100 meters. Okay. So when I try to calculate the total time, do you think this error and this error, which had individual errors, will affect the overall quality? Are you able to understand what I'm asking? Means there are individually itself there are errors in T1 and in T2. But what is T? T is a combination of these two. So error from 1 and error from 2 will definitely create an impact on the overall reading. Is that accepted? So that is what we call it as combination of errors. Means if there is a physical quantity in this scenario, there is capital T, which is dependent on 2 other physical quantities. What are they? T1 and T2. So if there are errors in the individual readings, then in the combination also in the final output, you will have an error. How to calculate that error is what we are going to see in this particular subtopic. Is it clear? So right now the heading has combination of errors. So the first type of combination is errors that are occurring in sum and difference. Suppose I have two physical quantities A and B. For example, in our case, the example that we considered, what were they? T1 and T2. Okay. Suppose I have two physical quantities A and B whose measured values are. Generally, whenever you report a measured value, yesterday itself I told you, what will you do? You will report the true value plus or minus, you will report the relative error, or sorry, the average absolute error, right? So yesterday I wrote it, remember, A vector plus, sorry, A bar plus or minus delta A bar. Do you remember this? Right? So generally, whenever you take a measure, so what does this tell us? When you report something like this, what are you able to understand from that? You're able to understand the fact that A is not an absolute value. It has a plus or minus small variation compared to the actual reading that we have taken. So this is how you exactly need to report it. Okay. So suppose the two physical quantities have the measured value as A plus or minus delta A and B plus or minus delta B respectively, where delta A and delta B are called as what? Absolute errors. They are basically the average absolute errors. Then we want to find the error that is occurring in a physical quantity Z, such that Z is the combination of both in this one. Means I'm trying to say Z is some physical quantity, which is sum of two other physical quantities, A and B. But what is happening? A is having an error delta A and B is having an error delta B. So what do you think will be the error that will occur in the case of Z in terms of delta A and delta B? Is it clear? So shall I proceed with the mathematical part? Yes. There is any confusion, please speak up. Is it clear till this time? Right. Is this color okay? It's not too bright, no? Okay. Errors in sum or difference. Okay. So let's say there is a physical quantity Z, which is the sum of two other physical quantities A and B, which I'll call it as 1. Okay. Then what is the measured value of A? Measured value of A is true value plus or minus the average error. Then what is the measured value of B? B plus or minus delta B. Is that clear? Then what will be the measured value of Z? Z plus or minus delta Z, such that measured value of measured value of Z, can I say, is equal to the measured value of A plus measured value of B. Does that make sense? Right. Now you think about it. Z plus or minus delta Z is the measured value of Z, is equal to A, measured value of A plus or minus delta A plus measured value of B. Simple. Right. Now what will happen is Z plus or minus delta Z will be equal to A plus B plus or minus delta A plus or minus delta B. Or I write it as delta A plus delta B. Okay. To be more specific, right? I'll write it as plus or minus delta A plus or minus delta B. Is that right? Did you understand what I did? Now what can I cancel? Z and A plus B I can cancel. Since from 1 we know that Z is equal to A plus B. Is that clear? Right. So can I write plus or minus delta Z is equal to plus or minus delta A plus or minus delta B. So what is that you're left out with? Plus or minus delta z is equal to plus or a plus or minus delta a plus or minus delta b. So what is the maximum value of delta z that is possible? What is the maximum value of delta z that is possible? Maximum value of delta z should be positive. So you have plus or minus. So out of plus z and minus z, which one is maximum value? Plus z will be equal to the maximum value of error in the A, that is delta A, plus the maximum error in delta B, that is delta B. So this is what is the measured value in the combination of A and B. Is it here? Please make a note of it. So mostly try to write it on your own. If you have any doubt, look at the book. The book is clear, right? It's not they will ask you. That is the maximum value you need to report. Because if you know the maximum value, to the measured value, you can put plus or minus maximum value. It's simple. Maximum value is possible. Negative of maximum value will be negative of maximum value will be minimum value. So what is the meaning of the plus or minus is you're actually finding the range of values. So you're trying to say if I'm reading comes out to be 5 plus or minus 0.1, then you're trying to say with respect to 5, my maximum error that can occur is 0.1 or the least error that can occur is minus 0.1. Are you able to understand that? So that is why I try to find the maximum value. Now the point is, it is the same for z is equal to a minus b also. It is the same for z is equal to a minus b also. Is that clear? Right? Now what we can do is, now we'll see the product and division, product and quotient rule. That is, the second set is errors in product and quotient. Or you can call it as multiplication and division. You can call it as division. Okay, they generally don't use the word quotients everywhere. So, what is the meaning of this? If z is equal to a into b, right? I'll call this as equation number 1. Then, what is the measured value of z? Z plus or minus delta z. Measured value of a plus or minus delta a. Measured value of b plus or minus delta B. Is it right? So when you say Z is equal to AB, right? Can I say measured value of Z is equal to measured value of A into measured value of B? Can I say this? Right. When this is a scenario, measured value of Z is Z plus or minus delta Z is equal to measured value of A is A plus or minus delta A into right. Now see, I want everybody to concentrate. This is the trickiest part. You have two terms multiplied with two terms. So totally how many terms do you get? 4 terms. So what are the 4 terms that you are going to get? AB plus or minus A delta B plus or minus B delta A plus or minus delta A into delta B. Is that right? Is it right? Now what I will do is observe delta A and delta B are generally so small. Okay, they're so small. Have this in your mind. Now, what I will do, I'll divide equation 2 with Z on both sides. So I'll divide equation 2 with Z on both the sides. When I do this, what will I get? 1 plus or minus delta Z by Z is equal to AB divided by Z plus or minus A delta B divided by Z plus or minus B delta A divided by Z plus or minus delta A into delta B divided by Z. Is that right? Now see. 1 plus or minus delta Z by Z is equal to what is AB and how are AB and Z related? A to B is what? Z. So can I cancel this and this? Since AB is equal to Z, I cancel it. So I get a 1 here, plus or minus A into delta B by Z. Okay. Now see, A into delta B divided by Z, can I write it as AB? Plus or minus B delta A divided by again Z, I can write it as AB plus or minus delta A into delta B divided by Z, I can write it as again AB only. So 1 and 1 are gone. Plus or minus delta Z divided by Z is equal to plus or minus A and A will get cancelled. Delta B divided by B plus or minus B and B will get cancelled. Delta A divided by A plus or minus I can write it as delta A by A into delta B by B. But I gave you one important point that delta A and delta B are generally so small that the product of those two values divided by the original value, that is delta A by A into delta B by B, will be a negligible value. This will be a negligible value. You can ask me why did I even write it like that. For example, when you report a reading as 5.05 and 5.2.5, which is a more accurate reading? 5 plus or minus 0.5, 5 plus or minus 2.5. Which one seems to be more accurate? Please guess. 5 plus or minus 0.5. Why? You're almost there. If you can give the right logic, that is not. It is not minimum value. What? See, if I report an answer like this, I'm saying my true value is 5. And the percentage, the fractional error that I've occurred with this plus or minus 0.5. Whereas in the second case, 5 plus or minus 2.5. So 5 divided by 0.5, sorry, 0.5 divided by 5, is it going to be small or more compared to 2.5 divided by 5? 0.5 by 5 and 2.5 by 5, which value is more? That value is going to be more, right? So what can you say? This is having a lesser error compared to this one, means this is almost having 50% error. So what I'm trying to say here is, I told you delta A and delta B are generally small, right? When they are small, they are of this size values, 0.5 into let's say 0.1. So when you multiply 0.5 and 0.1, what happens? You get 0.05. Means the decimal values are being pushed to the right more. As a result of which, what we can say is the output value is very, very small. Means the product of delta A by A to delta B by B is almost a negligible value because of this reason. Okay. When that is the case, I can say that this value is approximated to 0. Now, what are you left out with? Plus or minus delta Z by Z is equal to plus or minus delta B by B plus or minus delta A by A. Okay. So, out of all the three values, what is the maximum value? Delta Z by Z is equal to delta A by A. So, I'm writing this first, plus delta B by B. Means if you have a physical quantity Z is equal to A into B, then if you want to find the error that is occurring in Z due to the errors in A and B individually, you can never find the average absolute error. Rather, you can only find, what is this error called as? The delta Z by Z is called what? I gave you three types of errors. You can only find fractional errors. So the important differentiating factor that you need to understand is, when you have sum or product of two physical quantities, you can find the sum of their average absolute errors. Whereas when you have Z is equal to product or divided by. Okay. So when you have it in, sorry, division, when you have it in that form, you can never find average absolute error. You can only find sum of fractional errors. So same is the case for Z is equal to A by B also. Note it down. We'll do some problems, then you will get more clarity. Okay. So shall I proceed? You can do. There's any doubts? Here? Right. Now we can try out a few problems. So we'll concentrate on problems only related to errors and units. First one, which of the following physical quantities is a derivative? Which of the following physical quantities is not a fundamental physical quantity in the SI system? You know how to read that? This is called as, yes, this is called as mu. Okay, it's a Greek letter. It's called as mu. Mu refers to 10 power minus 6. Mu is basically, in terms of mathematical language, you call it as micro. So how do you read it as 1 micrometer divided by 1, F stands for femto. Femto is 10 power minus 15. So 1 micrometer is 10 power minus 6 meter. Micro means 10 power minus 6. Femto is 10 power minus 15 meter. So when you solve this, you get the answer as 10 power 9. So you wrote it only as 10 power 9 because meter and meter also got cancelled. And you are left out only with the fractional value, and that fractional value is 10 power 9. Is that clear? Fourth, unit of plane angle in SI systems, radian. Now comes an important question. 15th one, the percentage error in the distance. So they are reporting the measurement of some distance, which is 125 plus or minus 0.5. Okay. So what is this distance plus or minus delta d? So how do you calculate the fractional value? Formula is delta d divided by d into 100. How much is delta d? 0.5 divided by d is 125 into 100. So this goes 4 times, this goes 5 times. So you get 0.1 into 4, which is 0.4%. Hope I'm not fast. You're able to understand. So it is 0.4%. So leave some space for 6th. First I'll do 7th. Leave this much space. So first I'll do 7th, then I'll do 6th. So they're saying there is a physical quantity Z is equal to AQ, and you need to find the relative error in the measurement of Z. Okay. So Z is equal to A cube. Can I write it as Z is equal to A into A into A? So last derivation you saw Z is equal to AB, right? So it's not necessary that A should be only multiplied with some other physical quantity. It can be multiplied with itself also. Then what would have been the value of delta Z by Z? It would have been according to the previous formula. Delta Z by Z in the derivation, what did we write? So delta Z by Z would have been delta A by A plus delta A by A plus delta A by A. Why did we write it 3 times? Because it was multiplied with itself thrice. So what will delta Z by Z in the final value be? So delta A by A added to itself thrice. So what is the answer? 3 times delta A by A. So this will be the answer. So what I'm trying to tell from here is, listen to this first, then you can write it. If at all you have a physical quantity Z is equal to A power N and B power N, or A power M into B power N. So this is also product only, right? But product has some power. That power is generally called as index. Okay. Then delta Z by Z will be equal to M times delta A by A plus N times delta B by B. Why did we get that? Because A is multiplied with itself M times. So your delta A by A will be added to delta A by A M times. That is why we wrote it as M times delta A by A. Similarly, delta B by B is N times delta B by B. So to be more specific, right? So to be more specific, if there is a physical quantity Z is equal to A power small a, B power small b divided by C power small c and D power small d, then the formula is delta Z by Z. The relative error that is occurring in Z, where assuming A, B, C, D, everything has an error, will be equal to, you tell me, small a into delta A by A plus come plus only. I told you one thing, no? This kind of a pattern is the same even for division. Means if you have Z is equal to A by B, then you can say delta Z by Z is equal to delta A by A plus delta B by A. That is what happens. So when that is the scenario, you tell me now what will happen in this case. Plus C times delta C by C plus you have to understand. So this is the main mathematical equation based on which we need to solve problems. Because not every time the power of the physical quantities will be one. Not necessary. They will keep changing. Is it clear? So you understood what is the multiplication factor? The multiplication factor is the power of that term. Clear? Shall I proceed? Sixth one. In an experiment, so read the question carefully. In an experiment, to determine the density of a cube. So what is the formula for density of a cube? Density is equal to mass by volume. So to determine the density of a cube, the percentage error in the measurement of mass. So what is the percentage error written as? One minute. Okay, listen. In an experiment to determine the density of a cube, the percentage error in the measurement of mass. So delta m by m into 100 is how much? 0.26. And the percentage measurement in length, delta L by L into 100 is 0.38. Determine the percentage error in the density. So delta rho divided by rho into 100. So what is delta rho divided by rho? First of all, what is rho? M divided by V. So M divided by V is L cube. Right. So delta rho by rho will be equal to delta M by M into plus just I gave you the formula. Delta L by L is there, but what is the power of L? So 3 times delta L by L. So the percentage error. So the percentage error in density is equal to the percentage error in mass plus 3 times the percentage error in length. So delta rho by rho into 100 is equal to delta M by M into 100 plus 3 times delta L by L into 100. So what is delta M by M into 100? 0.26. Similarly, delta L by L into 100, 0.38. So this will give you the percentage error in density. So how much would be the answer? 0.26 plus 3 into 0.38. I think it is 1.04. To 1.14, no? We'll take 1.14. Right? So 0.26 plus 1.14 will give you 1.4. So 1.4 percentage is the percent error that is occurring in density. So that is 1.4%. Is it clear? So please make a note of this. Do the eighth one. X is equal to A by B. Delta A by A and delta B by B are the errors in measurement of A and B respectively. Then the maximum percentage error in the measurement of X is. So X is equal to A by B. Then what is delta X by X equal to? For product and division, it's the same thing. So delta X by X is equal to delta A by A plus delta B by B. So that is fractional error. But they are asking percentage. So you should multiply it with. So what is the right option? Is it clear? So leave the ninth one. Read the 10th one. The student performs an experiment for determination of G. G is the acceleration due to gravity, which is given by the formula 4 pi square L divided by T square, where T stands for the time period. Okay. So this formula and all we'll derive it in later chapters. We'll see. The error in delta L is delta L, and in time T is delta T, and N is the number of times readings were taken. N is the number of times readings were taken. The measurement of G is most accurate for which one? So they are given different set of data. In the data, which one do you think is the most accurate one? So first one, if you see delta L is 5 millimeter, delta T is 0.2 seconds, and N is 10, means the experiment was repeated 10 times. 5 millimeter, the second case 0.2 second, but the experiment was repeated 20 times. 5 millimeter, 0.1 seconds, the experiment was repeated 10 times. 1 millimeter, 0.1 seconds, 50 times the experiment was repeated. So which one would be more accurate? Option D is more accurate because the number of times the experiment was repeated is very much. Means the average value will be closer to the true value. Is it clear? So 11th one. When a current of 2.5 plus or minus 0.5 ampere flows through a wire, it develops a potential difference of 20 plus or minus 1 volt. The resistance in the wire is how much? R is equal to, what is the relation between resistance, potential difference and current? R is equal to V by I. So what I will do is R is equal to V by I means this is the value of I, this is the value of V. So 20 divided by 2.5, which will give me an 8. Okay. What is delta R? Delta R is delta V divided by delta I. So delta V is 1, delta I is 0.5. So 1 divided by 0.5, which will give me a 2. So when you report the answer, how will you report it? R plus or minus delta R. That is how the measured values are written. So R is how much? 8. Plus or minus delta R is 2. So which is the right option? So significant figures you can't do now. Dimensional formula also you can't do it now. So these are all the problems that are based on errors. So for other things, right, you need to understand some more concepts. So maybe these problems you can try it. So let's do the first one. In Ohm's experiment, the value of an unknown resistance were found to be 4.12, 4.08, 4.22, and 4.14. Calculate absolute error, relative error, and percentage error. Calculate absolute error, relative error, and percentage error. Even before you calculate all the errors, what is the first step? Find the average first. Find the average. $16.56 is the total. $4.14. Is that what everyone is getting? Average value is 4.14 ohm. Is that right? Okay. Now you need to find the absolute errors. So how you find the absolute error? It's very simple, I tell you. So A1 is 4.12 ohm. A2 is 4.08 ohm. A3 is 4.22 ohm. A4 is 4.14 ohm. Calculate the absolute error. So mean value got it as 4.14 ohm. Is it right? Next is you will find delta A or delta A1. Delta A1 is A value minus A1. So 4.14 minus 4.12. So that is 0.02 ohm. What is delta A2? A bar minus A2. A bar is 4.14 minus A2 is 4.08. So you'll get 0.06 ohm. Delta A3 is A bar minus A3. 4.14 minus 4.22, you will get minus 0.08 ohm. Delta A4, 4.14 minus 4.14, that is a 0. So what is delta A bar? This delta A4, the whole divided by 4. How much is this? 0.02 plus 0.06 plus 0.08 plus 0. The whole divided by 4. How much are you getting? 14.16 divided by 4, it should give you 0.4. So the relative error that is occurring is the average absolute error that is occurring is 0.4. Now what about the relative error? .4 divided by, that is delta A bar divided by A bar, that is 0.4 divided by calculate it, you will get the answer. Okay. What about percentage error? 0.4 divided by 4.14 into, that's the answer. Is it clear? So this is how you solve problems. Okay. This is all about errors and combination of errors. The next part that we are supposed to see is dimensions, about which we will try to complete it in the next week. Next week we will be done with this chapter. Then let's start with the next one. Actually, I go with vectors, but if you want integration and differentiation, I'll go with it. Whichever you want, I'm okay. So till here, any you have any physics will have. Math alone, sir, is not there. So chemistry and physics will happen as per schedule. So that's it from my side for today. You can practice some more problems from your textbook. You can revise and come. Next class we'll go with dimensions and dimensional analysis. That is very simple, you'll understand it. Okay. So with that, this chapter is over and we can do the remaining problems from this worksheet itself. So I'll upload this worksheet in the app. You can just go through the questions wherever you have written the solutions. You can go through the questions wherever needed. That's it, friends. Here, you can wind up. Hariharan?
Sir,
Yeah,
Thank
we
you,
can
sir.
wind up.
Thank you, sir.